Hi, let's take a look at a proof of the law of reflection using Huygen's principle. So what we could imagine are two rays of light that are heading towards a plane mirror traveling on parallel paths. And we'll sort of stop the travel of light in our minds for a brief moment when the first ray of light strikes the mirror. And we'll call that point A. And wherever that light ray is along the second path at that point, we'll call B. And because they're traveling on parallel paths at the same time, that line connecting A and B has to be at a 90-degree angle from the original travel path of that light. So, from Huygen's principle, what we're going to do is imagine taking a drawing compass and setting a distance for the travel of light here from B to C as our set distance for all points of light that we'd look at. So this distance here from B to C would be equal to the speed of light times the amount of time it'll take that light to get there. Now, I could take my drafting compass and then spin it around in a circle. The light that reflects out from point A is going to end up somewhere on that circle at a point D. But it's going to place itself so that after this second light ray reflects out at this point C, those two light rays are going to have to exit parallel to each other. So this side DC is also going to make a 90-degree angle with the travel path of the exiting light. So, in order to determine the law of reflection, we're going to go through and name some angles for these interior triangles that we've set up. So our first angle is our angle of incidence for our first light ray, theta 1, and the angle of reflection from the normal drawn here at point A to this ray AD is going to be my angle theta 1 prime. Now, for the light that travels from B to C, that segment B to C is parallel to my original segment, so that means then from a normal drawn at point C, I would also have an angle of theta 1 between segment BC and the normal at C. So, the angle between BC and AC, the distance between the two bounce points, I'm going to call gamma. And theta 1, the angle of incidence, plus gamma has to add up to 90 degrees, right? Normal. Now, the angle of reflection, theta 1 prime, I'm going to say that the angle on the other side of AD, between AD and AC, is called gamma prime. So theta 1 prime plus gamma prime also has to add up to 90 degrees. And if I look at triangles ABCA and triangles ADCA, both of those triangles are right triangles. And for ABCA, ABC makes up my 90-degree angle, so side AC is my hypotenuse. For triangle ADCA, ADC makes up my 90-degree angle, AC is once again my hypotenuse. Well, my angle gamma is part of triangle ABCA. And the cosine of gamma is going to be my adjacent side BC divided by my hypotenuse AC. My angle gamma prime is part of triangle ADCA. AD is my adjacent side, AC is my hypotenuse, so the cosine of gamma prime is equal to AD divided by AC. Well, we said from Huygen's principle, the travel distance from AD had to be exactly the same as the travel distance along BC. And since AC is the same side for both of those triangles, that means that the cosine of gamma has to equal the cosine of gamma prime. And that also means that gamma has to equal gamma prime. And if gamma equals gamma prime, then theta 1 plus gamma is going to have to equal theta 1 prime plus gamma, which is meaning that theta 1 has to equal theta 1 prime. The law of reflection. The angle of incidence is always equal to the angle of reflection from the normal of the mirror where that light ray strikes. Thanks for watching.